Close your eyes for a moment and picture this. A vast, silent expanse stretches above you, dotted with countless stars, but one celestial body captures your attention more than any other. The moon, glowing softly in the night sky, has been a constant companion to Earth for billions of years. It has inspired poets, guided explorers, and sparked the curiosity of scientists and dreamers alike. Yet, despite its familiarity, the moon holds secrets that have puzzled humanity for centuries. What lies hidden in its shadowed craters? What stories does its ancient surface tell? Tonight, as you settle in, let's journey together into the mysteries of the moon, a place where science and wonder meet. As we explore its unanswered questions, allow yourself to drift into a state of calm, letting the soothing rhythm of this story carry you into a peaceful sleep. And as we begin, I'd love to know, where are you joining us from, and what does the moon look like in your sky tonight? Share your thoughts in the comments below, and let's embark on this lunar adventure together. Now, turning to the very beginning, let's explore how the moon came to be. One of the most widely accepted theories is the giant impact hypothesis, a story of cosmic drama that unfolded over 4.5 billion years ago. Picture this: a young Earth, still forming and fiery, collides with a Mars-sized body, often referred to as Theia. The impact was so colossal that it sent massive amounts of debris hurtling into space. Over time, this debris began to coalesce, pulled together by gravity, eventually forming the moon as we know it today. Scientists have found evidence supporting this theory in the similarities between the composition of Earth's rocks and those brought back from the moon. The moon's rocks contain elements that match those found on Earth, suggesting a shared origin. This ancient collision not only shaped the moon, but also played a crucial role in shaping Earth's early environment, setting the stage for the planet we call home. As you imagine this fiery, chaotic event, let your mind drift into the vastness of space, where the moon's story began. Now, shifting our gaze to the moon's surface, we encounter one of its most striking features, the Lunar Maria. These vast, dark plains stretch across the moon, creating a stark contrast against the brighter highlands. But what exactly are these mysterious patches? Billions of years ago, the moon was a far more active place, with molten lava bubbling beneath its surface. When massive asteroid impacts cracked the moon's crust, this lava seeped through, flooding the low-lying basins. Over time, the lava cooled and solidified, forming the smooth, flat plains we see today. The reason these maria appear darker is due to their composition, rich in iron and magnesium, which absorb more light compared to the reflective, rocky highlands. These ancient lava flows are like a time capsule, offering us a glimpse into the moon's volcanic past. By studying the maria, scientists have uncovered clues about the moon's internal heat and the processes that shaped its surface. As you picture these vast, shadowy plains, imagine the fiery rivers of lava that once flowed across the moon, leaving behind a story etched in stone for us to unravel. Now, turning to the moon's hidden tremors, we uncover another layer of its mysteries: moonquakes. Much like earthquakes on our own planet, moonquakes are seismic events that shake the lunar surface. But unlike Earth's quakes, which are often caused by the shifting of tectonic plates, moonquakes have different origins. Some are triggered by the gravitational pull of Earth, creating tidal forces that stretch and compress the moon's interior. Others are the result of thermal expansion, as the moon's surface heats up under the sun's rays and cools rapidly in the shadow of night, causing the ground to crack and shift. There are even moonquakes caused by meteorite impacts, sending shockwaves through the lunar crust. What makes these quakes particularly fascinating is their depth. Some occur hundreds of kilometers below the surface, offering scientists a rare glimpse into the moon's inner layers. By studying these tremors, researchers can map the moon's interior, uncovering clues about its structure, composition, and even its history. Imagine standing on the moon, feeling the faint vibrations beneath your feet, as these subtle movements reveal secrets buried deep within. Moonquakes remind us that even in its stillness, the moon is alive with activity, quietly sharing its story with those who listen. Now shifting our gaze to the moon's enigmatic far side, we step into a realm that has long captivated both scientists and dreamers alike. Often referred to as the dark side, this hidden hemisphere is not dark in the sense of being devoid of light, but rather because it remains perpetually out of view from Earth. This is due to a phenomenon called tidal locking, where the moon's rotation matches its orbit around our planet, keeping one face always turned toward us. The far side, however, is anything but a mirror image of the familiar near side. While the near side is marked by vast, dark plains, known as Lunar Maria, the far side is dominated by rugged highlands and a dense scattering of craters. These craters, some of the largest in the solar system, tell a story of ancient bombardments that shaped the moon's surface billions of years ago. But why does the far side lack the smooth Maria that characterized the near side? Scientists believe it's tied to differences in the moon's crust, with the far side being thicker and less prone to volcanic activity. This asymmetry raises intriguing questions about the moon's formation and evolution. Adding to the mystery are strange features like the South Pole Aitken Basin, one of the largest and oldest impact craters in the solar system, and the unusual magnetic anomalies detected in certain regions. The far side remains a frontier of discovery, offering clues not just about the moon, but about the early history of our solar system. As we continue to explore this hidden landscape, we uncover not only the moon's secrets, but also our own place in the cosmos. Now turning to the moon's polar regions, we uncover one of its most intriguing secrets, the presence of water ice. Hidden within the shadowed depths of craters that never see sunlight, these icy deposits have sparked both scientific curiosity and practical excitement. For decades, the moon was thought to be a dry, barren world, but recent discoveries have shattered that assumption. Spacecraft like NASA, a lunar reconnaissance orbiter, and India's Chandrayaan-1 have detected unmistakable signs of water ice, particularly in the permanently shadowed craters near the moon's poles. These regions, some of the coldest places in the solar system, act as natural freezers, preserving water that may have been delivered by comets or formed through interactions with solar wind over billions of years. The discovery of lunar water is more than just a scientific breakthrough. It's a game changer for future exploration. Water is essential for human survival, and it can also be split into hydrogen and oxygen, providing breathable air and rocket fuel. Imagine a future where lunar bases harvest this ice, turning it into a vital resource for astronauts living and working on the moon. This vision is no longer science fiction. It's a tangible goal driving missions like NASA's Artemis program. But the mysteries of lunar water don't end there. Scientists are still unraveling its origins, debating whether it arrived through ancient impacts or was formed through chemical processes on the moon itself. As we peer into these icy craters, we're not just looking at frozen water, we're glimpsing the potential for humanity's next great leap into space. The moon's hidden reservoirs could hold the key to sustainable exploration, not just of our nearest neighbor, but of the solar system beyond. And as research continues, each discovery brings us closer to understanding how water, the essence of life, found its way to this seemingly barren world. Now shifting our gaze to another lunar enigma, we encounter the fleeting and mysterious flashes of light and color known as transient lunar phenomena. These brief, unpredictable events have puzzled astronomers for centuries, appearing as sudden glows, flickers, or even patches of color on the moon's surface. Unlike the steady, unchanging face we see from Earth, these phenomena suggest that the moon is far more dynamic than it appears. One of the leading theories points to gas releases from beneath the moon's surface. As the moon's interior cools and contracts, trapped gases like radon or carbon dioxide might escape through cracks, creating brief bursts of light as they interact with the lunar environment. Another possibility is the impact of meteorites, which can produce flashes as they collide with the moon's surface at high speeds. These impacts, though small, can release enough energy to create visible light, especially in the moon's dark, shadowed regions. Yet, despite these plausible explanations, transient lunar phenomena remain poorly understood. Their sporadic nature makes them difficult to study, and even with modern telescopes and spacecraft, capturing these events in real time is a rare and challenging feat. Some researchers have even speculated that these flashes could be linked to the moon's weak magnetic field or interactions with solar wind, adding another layer of intrigue to the mystery. What makes these phenomena so captivating is not just their mystery, but what they reveal about the moon's hidden activity. They remind us that even a world as familiar as the moon still holds secrets waiting to be uncovered. As we continue to observe and study these fleeting events, each flash of light brings us closer to understanding the moon's complex and ever-changing nature. And with every discovery, we're reminded that the moon, though silent and still, is far from lifeless. As we move forward, the next chapter of our journey takes us deeper into the moon's magnetic mysteries, where ancient forces continue to shape its enigmatic story. Now turning to the moon's magnetic field, we uncover yet another layer of its enigmatic nature. Unlike Earth, which boasts a strong and active magnetic field generated by its molten iron core, the moon's magnetic field is faint and patchy. This weak magnetism has long intrigued scientists, as it hints at a past that was far more dynamic than the moon's current quiet state. One of the leading theories suggests that the moon once had a molten core, much like Earth's, which generated a magnetic field through a process known as a dynamo effect. Over billions of years, as the moon's interior cooled and solidified, this dynamo may have faded, leaving behind only remnants of its former magnetic strength. These remnants could explain the localized magnetic anomalies detected on the moon's surface, where certain regions exhibit stronger magnetism than others. Another intriguing possibility is that the moon's magnetic field was influenced by external forces, such as interactions with Earth's magnetic field during its early history. Some researchers propose that the moon's close proximity to Earth in its formative years could have induced a temporary magnetic field, which later weakened as the moon drifted further away. Despite these theories, the moon's magnetic field remains a puzzle. The uneven distribution of magnetism across its surface defies simple explanations, and the lack of a global magnetic field raises questions about how such a field could have existed in the past. Adding to the mystery is the discovery of magnetic rocks in lunar samples brought back by the Apollo missions. These rocks, which are magnetized in ways that suggest they formed in the presence of a strong magnetic field, challenge our understanding of the moon's geological history. As we delve deeper into this magnetic mystery, we're reminded that the moon's story is far from complete. Each new discovery, whether from lunar samples or advanced spacecraft, brings us closer to unraveling the secrets of its magnetic past. And as we continue to explore, we're left to wonder what other surprises the moon might hold, waiting to be uncovered in the quiet expanse of space. With the next phase of our journey in sight, we turn our attention to the moon's surface, where swirling patterns of light and dark reveal yet another captivating mystery. As we shift our gaze to the moon's surface, we encounter one of its most visually striking mysteries, the lunar swirls. These bright, swirling patterns, resembling delicate brushstrokes on a cosmic canvas, stand out against the darker lunar terrain. Their origin has puzzled scientists for decades, and while they may appear purely artistic, they hold clues to the moon's complex history and its interactions with the forces of space. One of the most compelling theories links these swirls to the moon's magnetic field. Unlike Earth, which has a global magnetic shield, the moon's magnetism is scattered and uneven. Some of these magnetic anomalies align closely with the locations of lunar swirls, suggesting a possible connection. Scientists hypothesize that the swirls could be the result of interactions between the moon's magnetic field and the solar wind, a stream of charged particles constantly flowing from the sun. When the solar wind encounters the moon's surface, it darkens the regolith, the layer of loose, fragmented material covering the moon. However, in areas with stronger magnetic fields, the solar wind may be deflected, leaving the surface beneath it brighter and less weathered. This could explain why the swirls appear so luminous compared to their surroundings. Another intriguing idea is that the swirls might be remnants of ancient cometary impacts. When a comet collides with the moon, it could create a temporary magnetic field, altering the surface in ways that leave behind these bright, swirling patterns. Over time, these changes could become frozen in the lunar landscape, preserving a record of the event. Despite these theories, the true nature of lunar swirls remains elusive. Their formation could involve a combination of factors, from magnetic interactions to geological processes we have yet to fully understand. What makes them even more fascinating is their potential to reveal not just the moon's past, but also the broader dynamics of how celestial bodies interact with their environments. As we continue to explore these enigmatic features, we're reminded that the moon is far more than a silent, unchanging companion. Its surface tells a story of cosmic forces, ancient events, and mysteries waiting to be unraveled. And with each discovery, we come closer to understanding not just the moon, but the intricate dance of the universe itself. With this in mind, we now turn our attention to the moon's atmosphere, or rather, its lack thereof, and explore how this tenuous layer of gas shapes the lunar environment. Now, as we lift our gaze from the moon's surface, we enter the realm of its atmosphere, or more accurately, its exosphere. Unlike Earth's thick, life-sustaining blanket of air, the moon's atmosphere is incredibly thin, almost imperceptible. In fact, it's so sparse that scientists often refer to it as an exosphere, a term used to describe the faintest layer of gas surrounding a celestial body. The moon's exosphere is composed of trace amounts of gases like helium, argon, neon, and even small traces of hydrogen. These gases don't form a cohesive atmosphere like Earth's. Instead, they exist as individual particles, scattered and isolated. Some of these gases are released from the moon's interior through a process called outgassing, while others are delivered by the solar wind or micrometeorite impacts. Studying the moon's exosphere is no easy task. Its extreme thinness makes it nearly impossible to detect with traditional instruments. Scientists rely on sensitive equipment aboard lunar orbiters and landers to measure these faint traces of gas. Even then, the data is often limited, leaving many questions unanswered about how the exosphere behaves and evolves over time. One of the most intriguing aspects of the moon's exosphere is its dynamic nature. Unlike Earth's atmosphere, which remains relatively stable, the moon's exosphere changes dramatically depending on the time of day. During the lunar day, when the surface is bombarded by sunlight, temperatures soar, causing gases to escape into space. At night, the surface cools, and some gases may temporarily settle back onto the surface. This constant ebb and flow creates a delicate balance, one that scientists are still working to fully understand. The moon's exosphere also plays a subtle but important role in shaping the lunar environment. For example, the presence of certain gases can influence the behavior of dust on the moon's surface, causing it to levitate or cling to equipment. This phenomenon, known as electrostatic dust transport, has been a challenge for lunar missions, as it can interfere with instruments and even pose risks to astronauts. As we continue to explore the moon's exosphere, we gain not only a deeper understanding of our closest celestial neighbor, but also insights into the broader processes that govern the atmospheres of other airless bodies in our solar system. Each discovery brings us closer to unraveling the mysteries of how these tenuous layers of gas form, evolve, and interact with their surroundings. With this in mind, we now turn our attention to the layer of loose, fragmented material covering the moon's surface, the lunar regolith, and explore how it holds clues to the moon's ancient past and its potential for future exploration. Now, as we shift our focus to the moon's surface, we encounter a layer that tells a story billions of years in the making, the lunar regolith. This blanket of loose, fragmented material covers the moon's surface, a testament to the countless impacts and cosmic events that have shaped our celestial neighbor over eons. The regolith is a mix of fine dust, broken rock, and mineral fragments, created by the relentless bombardment of meteoroids over millions and millions of years. Each impact shatters the moon's surface, grinding rocks into smaller and smaller pieces until they form the fine, powdery layer we see today. This process, known as space weathering, also includes the effects of solar wind and cosmic rays, which further alter the regolith's composition. What makes the regolith so fascinating is its complexity. It's not just a uniform layer of dust. It varies in thickness and composition across the moon's surface. In some areas, it can be as shallow as a few centimeters, while in others, it reaches depths of several meters. This variation provides clues about the moon's geological history, revealing where impacts were more frequent or where ancient lava flows once reshaped the landscape. The regolith is also a treasure trove of information about the moon's past. Embedded within it are tiny glass beads, formed during volcanic eruptions billions of years ago, as well as fragments of meteorites that have struck the moon over time. These materials offer scientists a window into the early solar system, helping us piece together the story of how the moon and even Earth came to be. But the regolith isn't just a relic of the past. It holds promise for the future. One of the most exciting possibilities is its potential as a resource for future lunar missions. The regolith contains elements like oxygen, silicon, and even traces of water ice, which could be extracted and used to support human exploration. Imagine a future where astronauts use the moon's own soil to produce breathable air, build habitats, or even fuel spacecraft. However, working with regolith presents its own set of challenges. Its fine, abrasive particles can clog machinery, damage equipment, and even pose health risks to astronauts if inhaled. Scientists and engineers are actively researching ways to mitigate these challenges, developing technologies to safely handle and process regolith for practical use. As we delve deeper into the mysteries of the lunar regolith, we uncover not only the moon's ancient history, but also the potential for a new era of exploration and discovery. This layer of dust and rock, once seen as a barren wasteland, is now recognized as a key to unlocking the moon's secrets and perhaps our future among the stars. With this understanding, we now turn our gaze to the moon's countless craters, each one a record of the cosmic collisions that have shaped its surface and our understanding of the solar system. Now, as we shift our gaze to the moon's surface, we are met with a landscape marked by countless craters, each one a silent witness to the violent history of our solar system. These craters, formed by meteorite impacts over billions of years, tell a story of cosmic collisions that have shaped not only the moon, but also our understanding of the universe itself. Among these craters, one stands out as a true giant, the South Pole Aitken Basin. This colossal impact site, stretching over 2,500 kilometers in diameter and plunging to depths of up to 13 kilometers, is one of the largest known craters in the solar system. Its immense size and depth offer scientists a unique window into the moon's interior, revealing layers of rock and material that would otherwise remain hidden beneath the surface. The South Pole Aitken Basin is more than just a scar on the moon's surface. It's a treasure trove of geological information. The impact that created it was so powerful that it likely excavated material from the moon's mantle, providing researchers with rare samples of the moon's deeper layers. These materials, now scattered across the basin, hold clues about the moon's formation and evolution, offering insights into the processes that shaped not only our celestial neighbor, but also the early solar system. But the South Pole Aitken Basin is just one of many craters that dot the moon's surface. Each crater, from the smallest to the largest, tells its own story. Some craters, like Tycho and Copernicus, are relatively young, their sharp rims and bright rays of ejected material still clearly visible. Others, like the ancient and heavily eroded Clavius, bear the marks of billions of years of space weathering, their once pristine features softened by time. These craters are more than just geological features. They are time capsules, preserving a record of the moon's history. By studying their sizes, shapes, and distributions, scientists can piece together a timeline of the moon's past, identifying periods of intense bombardment and quieter eras of relative calm. This information not only helps us understand the moon's history, but also sheds light on the broader history of the solar system, including the frequency and intensity of impacts that have shaped planets and moons alike. As we explore these craters, we are reminded of the dynamic and ever-changing nature of our universe. Each impact, each collision has left its mark, shaping the moon into the world we see today. And as we continue to study these features, we uncover not only the moon's past, but also the potential for future discoveries, as these ancient scars may hold the key to unlocking new mysteries of our solar system. With this in mind, we now turn our attention to the moon's interior, where seismic data and gravity measurements have revealed a hidden world beneath the surface, waiting to be explored. As we venture deeper into the moon's mysteries, let's turn our attention to what lies beneath its rugged surface. Beneath the layer of regolith and the countless craters, the moon hides a complex interior, much like Earth, with a crust, mantle, and core. But unlike our planet, the moon's internal structure holds secrets that continue to intrigue scientists and spark curiosity. The moon's crust, the outermost layer, is a thin shell of solid rock, ranging from about 30 to 50 kilometers thick on the near side and up to 100 kilometers on the far side. This difference in thickness is one of the many puzzles scientists are trying to solve. What caused this asymmetry? Was it the result of ancient impacts, or does it hint at deeper processes within the moon's formation? Beneath the crust lies the mantle, a thick layer of dense rock that makes up the bulk of the moon's interior. Seismic data from the Apollo missions reveal that the mantle is solid, but not entirely uniform. It contains regions of varying density, suggesting that the moon's interior was once molten and has since cooled and solidified over billions of years. This cooling process likely played a role in shaping the moon's surface, including the formation of its vast lava plains, known as the Lunar Maria. At the very center of the moon lies its core, a small but fascinating region that has been the subject of much debate. Gravity measurements and seismic data suggest that the moon's core is partially molten, with a solid inner core surrounded by a liquid outer layer. This discovery challenges earlier assumptions that the moon's core was entirely solid. But why does the moon have a partially molten core? Some scientists believe it's a remnant of the moon's early history, when it was still hot and active, while others think it might be influenced by tidal forces from Earth. Despite these insights, many questions about the moon's interior remain unanswered. For instance, how did the moon's core form, and what role did it play in the moon's magnetic field, which was once much stronger than it is today? Why does the moon's far side have a thicker crust than the near side? And what can the moon's interior tell us about the early solar system and the processes that shaped other rocky bodies? As we continue to study the moon's interior, we uncover not only its hidden layers, but also clues about the broader history of our solar system. Each seismic wave, each gravity measurement, brings us closer to understanding the moon's past and its connection to Earth. And as we look to the future, with new missions and advanced technologies, we may finally unlock the secrets that lie beneath the moon's surface, revealing a story that has been waiting to be told for billions of years. With this deeper understanding of the moon's interior, we now turn our gaze to another fascinating aspect of lunar history, its ancient volcanic activity, which once shaped its surface in dramatic ways. As we shift our focus to the moon's fiery past, let's explore the remnants of its ancient volcanic activity, a chapter that once painted its surface with molten rock and dramatic landscapes. Billions of years ago, the moon was a far more dynamic place, with volcanic eruptions shaping its surface in ways that still captivate scientists today. One of the most striking features left behind by this volcanic activity is the Lunar Maria, the dark, smooth plains that cover much of the moon's near side. These vast plains were formed by massive lava flows that filled enormous impact basins, creating the flat, dark regions we see today. But the moon's volcanic history goes beyond these plains. Scattered across its surface are volcanic domes, small, rounded hills formed by the slow eruption of thick lava. These domes, often found near the edges of the Maria, offer a glimpse into the moon's more subtle volcanic processes. Another fascinating feature is the presence of lava tubes, underground tunnels formed by flowing lava. As the surface of a lava flow cooled and solidified, the molten rock beneath continued to move, eventually draining away and leaving behind hollow tubes. These structures, some of which are large enough to house entire cities, could play a crucial role in future lunar exploration, providing natural shelters from the harsh conditions on the surface. But why did the moon's volcanic activity stop? The answer lies in its small size. Unlike Earth, which remains geologically active due to its large, heat-retaining core, the moon cooled rapidly after its formation. As its interior lost heat, the magma that once fueled its volcanoes solidified, bringing an end to its volcanic era. Today, the moon is considered geologically dead, with no active volcanoes or tectonic activity. Yet, the evidence of its volcanic past remains etched into its surface, offering clues about its early history. By studying these features, scientists can piece together the story of how the moon evolved from a molten, fiery world to the quiet, cratered companion we see today. And as we look to the future, these ancient volcanic structures may hold the key to unlocking new possibilities for lunar exploration and even colonization. With the moon's volcanic history now behind us, we turn our attention to its orbit, a dance with Earth that has shaped not only its appearance, but also its influence on our planet. Now turning to the moon's orbit, we find a celestial dance that has fascinated observers for centuries. The moon orbits Earth in a path that takes roughly 27 days to complete, a journey that keeps it forever locked in a gravitational embrace with our planet. But what makes this orbit truly unique is the moon's synchronous rotation, a phenomenon where it rotates on its axis at the same rate it orbits Earth. This means we always see the same side of the moon, a face that has become familiar to us over millennia. Yet, the moon's orbit isn't perfectly uniform. A subtle wobble, known as libration, allows us to catch glimpses of its far side over time. Libration occurs because the moon's orbit is slightly elliptical, and its axis is tilted relative to Earth. This gentle rocking motion means that, over time, we can see up to 59% of the moon's surface from Earth, even though only one side is permanently visible. It's as if the moon is offering us fleeting peeks into its hidden mysteries. These orbital characteristics have profound implications for lunar exploration. The moon's synchronous rotation means that any long-term base on its near side would always have a direct line of communication with Earth, a crucial advantage for missions. Meanwhile, the far side, shielded from Earth's radio noise, offers a unique opportunity for astronomical observations, free from interference. As we continue to study the moon's orbit, we uncover more about its influence on Earth, from the tides that shape our coastlines to the subtle gravitational forces that stabilize our planet's axial tilt. This intricate relationship between Earth and the moon is a reminder of how interconnected our cosmic neighborhood truly is. With the moon's orbit now in focus, we prepare to delve into the captivating phenomenon of lunar eclipses, where Earth's shadow transforms the moon into a canvas of deep reds and coppers, a sight that has inspired awe and wonder throughout human history. As we shift our gaze to the night sky, let us explore the mesmerizing phenomenon of lunar eclipses, where Earth's shadow transforms the moon into a breathtaking spectacle of deep reds and coppers. A lunar eclipse occurs when Earth moves directly between the sun and the moon, casting its shadow across the lunar surface. This celestial alignment can only happen during a full moon, when the moon is on the opposite side of Earth from the sun, creating the perfect conditions for this dramatic event. There are three main types of lunar eclipses: total, partial, and penumbral. During a total lunar eclipse, the moon passes completely into Earth's umbra, the darkest part of its shadow. This is when the moon takes on its iconic reddish hue, often referred to as a blood moon. This striking color is caused by sunlight filtering through Earth's atmosphere, bending and scattering shorter blue wavelengths, while allowing longer red wavelengths to reach the moon. Partial lunar eclipses occur when only a portion of the moon enters the umbra, creating a striking contrast between light and shadow. Penumbral eclipses, on the other hand, are more subtle, as the moon passes through Earth's outer shadow, resulting in a faint dimming that can be harder to notice. Lunar eclipses have held profound significance across cultures and civilizations. In ancient times, they were often seen as omens or messages from the gods, inspiring myths and rituals. For example, some cultures believed eclipses were caused by celestial creatures devouring the moon, while others saw them as moments of transformation or renewal. Today, lunar eclipses continue to captivate us, not only for their beauty, but also for the scientific insights they provide. By studying the way Earth's atmosphere filters sunlight during an eclipse, scientists can learn more about our planet's atmospheric composition and even gain clues about the atmospheres of distant exoplanets. As we marvel at the beauty of lunar eclipses, we are reminded of the intricate dance between Earth, the Moon, and the Sun, a dance that has shaped our understanding of the cosmos and our place within it. With this celestial wonder fresh in our minds, we now turn to the history of lunar exploration, where humanity's quest to uncover the moon's secrets began to take flight. As we step into the next chapter of our lunar journey, let us trace the footsteps of humanity's relentless pursuit to uncover the moon's secrets. The story of lunar exploration is one of curiosity, ingenuity, and determination, spanning centuries of observation and discovery. It begins long before the first rockets soared into the sky, with early astronomers peering through rudimentary telescopes to map the moon's surface and ponder its mysteries. In the early 17th century, Galileo Galilei turned his telescope toward the moon, revealing its rugged terrain of mountains, valleys, and craters. This groundbreaking observation shattered the ancient belief that the moon was a perfect, smooth sphere, opening the door to a new era of scientific inquiry. Over the centuries, telescopes grew more powerful, allowing astronomers to study the moon in greater detail and fueling dreams of one day reaching its surface. The 20th century marked a turning point in lunar exploration, as the space race between nations propelled humanity closer to the moon than ever before. In 1959, the Soviet Union's Luna 2 became the first human-made object to reach the moon, crashing into its surface and marking a historic milestone. Just a decade later, in 1969, the world watched in awe as Apollo 11 astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface. Their iconic words, "That's one small step for man, one giant leap for mankind," echoed across the globe, symbolizing a triumph of human ambition and collaboration. The Apollo missions not only brought back invaluable lunar samples, but also revolutionized our understanding of the moon's geology, history, and origins. Scientists discovered that the moon's surface is covered in a layer of fine, powdery dust called regolith, formed by billions of years of meteorite impacts. They also uncovered evidence of ancient volcanic activity, suggesting that the moon was once a dynamic and geologically active world. Beyond the Apollo program, robotic missions like the Lunar Reconnaissance Orbiter and China's Chang missions have continued to map the moon's surface, search for water ice, and prepare for future human exploration. These efforts have revealed new insights into the moon's polar regions, where permanently shadowed craters may hold frozen water, a potential resource for future lunar colonies. As we reflect on the history of lunar exploration, we are reminded of how far we've come and how much more there is to discover. Each mission, whether manned or robotic, has brought us closer to unraveling the moon's mysteries and understanding its role in the story of our solar system. With this foundation of knowledge, we now look ahead to the next frontier of lunar exploration, where new missions and technologies promise to unlock even more secrets of our celestial neighbor. Now turning to the Apollo missions, we delve into one of humanity's most extraordinary achievements, landing humans on the moon. The Apollo program, initiated by NASA in the 1960s, was a monumental effort that combined cutting-edge technology, bold vision, and the courage of astronauts who ventured into the unknown. Over the course of 6 successful lunar landings between 1969 and 1972, the Apollo missions not only fulfilled President John F. Kennedy's dream of reaching the moon, but also transformed our understanding of Earth's closest celestial neighbor. Each Apollo mission was a carefully orchestrated symphony of science and exploration. Astronauts conducted a wide range of experiments on the lunar surface, from deploying seismometers to measure moonquakes to setting up retroreflectors that allowed scientists to precisely measure the distance between the Earth and the moon using lasers. These experiments provided invaluable data, revealing insights into the moon's internal structure, its seismic activity, and even its relationship with Earth. Perhaps the most enduring legacy of the Apollo missions lies in the lunar samples they brought back to Earth. Over 800 pounds of moon rocks and soil were collected during the Apollo program, offering scientists a treasure trove of information about the moon's composition and history. Analysis of these samples revealed that the moon's surface is much older than previously thought, with some rocks dating back more than 4 billion years. They also provided evidence of ancient volcanic activity, suggesting that the moon was once a geologically active world with a molten interior. The Apollo missions also left behind instruments and equipment that continue to provide data to this day. For example, the retroreflectors placed on the moon's surface by Apollo astronauts are still used in experiments to measure the moon's gradual drift away from Earth, a phenomenon that helps us understand the dynamics of our planet-moon system. Beyond their scientific contributions, the Apollo missions captured the imagination of people around the world. The iconic images of astronauts walking on the moon, planting the American flag, and gazing back at Earth from the lunar surface became symbols of human ingenuity and the spirit of exploration. These missions demonstrated what humanity could achieve when driven by curiosity, collaboration, and a shared sense of purpose. As we reflect on the Apollo program, we are reminded of its profound impact on science, technology, and culture. It not only advanced our knowledge of the moon, but also inspired generations to dream big and reach for the stars. The legacy of Apollo continues to shape our aspirations for space exploration, serving as a reminder that the moon is not just a destination, but a stepping stone to even greater discoveries in the cosmos. Now shifting our focus to the lunar samples, we uncover the tangible treasures brought back by the Apollo mission's moon rocks and soil. that have become some of the most studied materials in the history of science. These samples, collected by astronauts during their time on the lunar surface, have opened a window into the moon's ancient past and its relationship with Earth. The moon rocks, ranging from fine-grained dust to larger fragments, have revealed a wealth of information about the moon's composition. Scientists discovered that the lunar surface is primarily made up of minerals like plagioclase, pyroxene, and olivine, which are also found on Earth. However, the moon's rocks lack water-bearing minerals, confirming that it is an incredibly dry place compared to our planet. This discovery has helped researchers understand the differences in how the moon and Earth formed and evolved over billions of years. One of the most significant findings from these samples is the moon's age. By analyzing the radioactive isotopes within the rocks, scientists determined that the moon is approximately 4.5 billion years old, nearly as old as the solar system itself. This age aligns with the giant impact hypothesis, supporting the idea that the moon formed from the debris of a colossal collision between Earth and a Mars-sized body early in our solar system's history. The lunar soil, or regolith, has also provided clues about the moon's history. Tiny glass beads found in the soil were formed by the intense heat of meteorite impacts, offering evidence of the moon's long history of bombardment. These beads, along with other minerals, have helped scientists piece together a timeline of the moon's volcanic activity, which was once far more active than it is today. What makes these samples truly invaluable is their ability to serve as a time capsule. Unlike Earth, where geological processes like erosion and plate tectonics constantly reshape the surface, the moon's surface has remained relatively unchanged for billions of years. This means that the rocks and soil collected by the Apollo missions preserve a record of the early solar system, providing insights not just about the moon, but also about the conditions that shaped Earth and other planets. Even today, decades after the Apollo missions, these lunar samples continue to yield new discoveries. Advances in technology have allowed scientists to analyze the samples with greater precision, uncovering details that were previously undetectable. For example, recent studies have identified traces of water in some lunar minerals, challenging earlier assumptions about the moon's dryness and opening new questions about its history. The Apollo lunar samples are more than just rocks. They are a bridge to understanding our cosmic neighborhood. They remind us that the moon is not just a distant object in the night sky, but a key to unlocking the mysteries of our solar system's origins. As researchers continue to study these precious materials, they pave the way for future missions that will bring back even more samples, deepening our knowledge of the moon and beyond. Now, as we gaze toward the horizon of lunar exploration, the future of moon missions shines brighter than ever. With the Artemis program leading the charge, NASA is preparing to return humans to the lunar surface for the first time in over 50 years. But this time, the goal is not just to visit, it's to stay. Artemis aims to establish a sustainable human presence on the moon, paving the way for long-term exploration and even the possibility of lunar colonization. This ambitious program plans to land the first woman and the next man on the moon, with a focus on exploring the lunar South Pole, a region rich in water ice and scientific potential. Artemis is just one piece of a larger puzzle. International efforts are also gaining momentum, with countries like China, India, and Russia launching their own lunar missions. China's Chang program, for example, has already achieved remarkable milestones, including the first ever landing on the far side of the moon. These missions are not only expanding our understanding of the moon, but also fostering global collaboration in space exploration. Together, these initiatives aim to unlock the moon's remaining mysteries, from its geological history to the potential resources it holds. One of the most exciting aspects of these future missions is the focus on sustainability. Unlike the Apollo missions, which were primarily about exploration and discovery, Artemis and its counterparts are designed to lay the groundwork for a lasting human presence. This includes developing technologies for extracting and utilizing lunar resources, such as water ice, which could be converted into drinking water, oxygen, and even rocket fuel. By harnessing these resources, future missions could reduce the need to transport supplies from Earth, making lunar exploration more efficient and cost-effective. Another key goal is to use the moon as a testing ground for technologies and systems that could one day support human missions to Mars and beyond. The moon's proximity to Earth makes it an ideal location to practice living and working in a harsh, extraterrestrial environment. Lessons learned on the moon will be invaluable as humanity takes its next giant leap into the solar system. As we look ahead, the moon remains a beacon of discovery and possibility. These upcoming missions promise to deepen our understanding of our closest celestial neighbor, while opening new doors for exploration and innovation. The moon is no longer just a destination, it's a stepping stone to the stars, and as these missions unfold, they will bring us closer to answering the enduring questions about our place in the universe. Now, as we turn our gaze toward the possibilities of lunar colonization, let's imagine what it might be like to call the moon home. Picture a future where humans live and work on the lunar surface, not as visitors, but as settlers. This vision, once confined to the realm of science fiction, is now within the realm of possibility. But living on the moon comes with its own set of challenges, each requiring innovative solutions and careful planning. One of the most pressing challenges is protecting lunar inhabitants from the harsh environment. Unlike Earth, the moon has no atmosphere to shield it from harmful solar radiation and cosmic rays. Prolonged exposure to these high-energy particles could pose serious health risks, including an increased likelihood of cancer and other radiation-related illnesses. To address this, future lunar bases will need robust shielding, possibly using materials like regolith, the moon's own soil, to create protective barriers. Another approach could involve building habitats underground or within lava tubes, natural tunnels formed by ancient volcanic activity, which would provide additional protection from radiation. Resource utilization is another critical factor in making lunar colonization sustainable. Transporting supplies from Earth is costly and inefficient, so future settlers will need to rely on the moon's own resources. Water ice, found in the permanently shadowed craters at the lunar poles, could be a game changer. This ice could be harvested and converted into drinking water, oxygen for breathing, and even hydrogen and oxygen for rocket fuel. By using these resources, lunar colonies could become self-sufficient, reducing their dependence on Earth and paving the way for long-term habitation. Building infrastructure on the Moon also presents unique challenges. The lack of gravity, only 1/6 of Earth's, means that construction techniques and materials will need to be adapted. Lunar dust, known as regolith, is another obstacle. This fine, abrasive material can damage equipment and pose health risks if inhaled. Engineers will need to develop new technologies to mitigate these issues, from dust-resistant machinery to advanced filtration systems for habitats. Despite these challenges, the potential benefits of a permanent lunar settlement are immense. The Moon could serve as a hub for scientific research, offering unparalleled opportunities to study the lunar environment, conduct experiments in low gravity, and observe the universe from a unique vantage point. It could also act as a testing ground for technologies and systems that could one day support human missions to Mars and beyond. By learning to live and work on the Moon, we would gain valuable experience that could help us tackle the even greater challenges of deep space exploration. Moreover, a lunar colony could open up new economic opportunities. The Moon is rich in valuable resources, such as rare earth metals and helium-3, a potential fuel for future fusion reactors. Mining and utilizing these resources could drive innovation and create new industries, both on the Moon and on Earth. Additionally, the Moon's proximity to Earth makes it an ideal location for space tourism, offering a once-in-a-lifetime experience for those willing to make the journey. As we envision this future, it's clear that lunar colonization is not just about survival, it's about thriving. It's about pushing the boundaries of what's possible and expanding the horizons of human potential. The Moon, with its mysteries and challenges, offers us a chance to build a new chapter in our story, one where humanity becomes a multi-planetary species. And as we take these first steps toward making the Moon our second home, we move closer to unlocking the secrets of the universe and securing our place among the stars. As we shift our focus from the Moon's potential as a future home, let's turn our attention to the profound influence it has on our own planet, Earth. The Moon, though distant, plays a vital role in shaping the world we know today. Its gravitational pull is the driving force behind one of the most familiar natural phenomena, the tides. Twice a day, the Moon's gravity tugs at Earth's oceans, causing them to rise and fall in a rhythmic dance. These tides are not just a spectacle, they are essential for marine ecosystems, influencing the behavior of countless species and even shaping coastlines over time. But the Moon's impact goes far beyond the ebb and flow of the seas. It also acts as a stabilizing force for Earth's axial tilt, which is the angle at which our planet leans relative to its orbit around the Sun. Without the Moon, Earth's tilt could vary dramatically over time, leading to extreme and unpredictable climate shifts. Imagine a world where seasons change erratically, with scorching summers and freezing winters occurring at random. The Moon's presence helps maintain a relatively stable tilt, ensuring a more predictable and hospitable climate for life to thrive. The moon's influence extends to the very rhythm of life on Earth. Many organisms, from tiny plankton to larger animals, have evolved to synchronize their behaviors with the lunar cycle. For example, some species of coral time their spawning events to coincide with the full moon, while nocturnal animals rely on moonlight to navigate and hunt. Even humans, though we may not always realize it, have been shaped by the moon's presence. Early civilizations used the lunar cycle to track time, creating calendars that guided agriculture, rituals, and daily life. Beyond its immediate effects, the moon has also played a crucial role in Earth's geological history. Some scientists believe that the moon's formation, through the collision of a Mars-sized body with Earth, may have contributed to the development of Earth's magnetic field. This magnetic field, in turn, protects our planet from harmful solar radiation, making life as we know it possible. In this way, the moon is not just a companion in the sky, it is a key player in the story of Earth's evolution. As we reflect on the moon's influence, it's clear that this celestial neighbor is more than just a distant rock. It is a silent guardian, shaping our planet's environment and ensuring the stability that allows life to flourish. From the tides that shape our shores to the seasons that define our year, the moon's presence is woven into the very fabric of our existence. And as we continue to explore its mysteries, we gain a deeper appreciation for the delicate balance that sustains life on Earth, and perhaps one day beyond. Now, as we journey into the realm of imagination and ancient wisdom, let's explore how the moon has inspired myths and legends across cultures. For thousands of years, the moon has been more than just a celestial body. It has been a source of wonder, mystery, and storytelling. Ancient civilizations looked to the moon and saw not just a glowing orb in the sky, but a canvas for their deepest fears, hopes, and beliefs. In many cultures, the moon was personified as a deity. The ancient Greeks worshipped Selene, the goddess of the moon, who rode her silver chariot across the night sky, casting her gentle light over the earth. Similarly, in Hindu mythology, Chandra, the moon god, was believed to influence emotions and the tides, symbolizing the connection between the heavens and the human experience. These deities often represented the moon's dual nature, its ability to bring both light and darkness, growth and decay. Lunar eclipses, with their dramatic darkening of the moon, were often seen as omens or battles between cosmic forces. The ancient Chinese believed that a dragon was devouring the moon during an eclipse, and they would bang drums and pots to scare the beast away. In Norse mythology, eclipses were linked to the wolves Hati and Skal, who chased the sun and moon across the sky. When they caught their prey, darkness fell, but the light always returned, symbolizing the eternal cycle of life and renewal. The moon's phases also played a central role in shaping myths. Many cultures saw the waxing and waning of the moon as a metaphor for life cycles: birth, growth, death, and rebirth. The Aztecs, for example, believed that the moon was created when the god Quetzalcoatl sacrificed himself to bring light to the world, and its phases reflected his ongoing struggle against darkness. In some Native American traditions, the full moon was a time of celebration and reflection, while the new moon symbolized new beginnings and fresh starts. Even today, the moon continues to inspire stories and traditions. From werewolf legends tied to the full moon to the romantic notion of moonlight as a symbol of love and longing, the moon's influence on human imagination remains as strong as ever. These myths remind us that the moon is not just a scientific curiosity, it is a timeless symbol of mystery, beauty, and the enduring connection between humanity and the cosmos. As we reflect on these ancient tales, we see how the moon has been a mirror for human emotions and aspirations, a celestial storyteller weaving its light into the fabric of our shared history. And as we continue to explore its mysteries, we carry forward the legacy of those who first looked up at the night sky and saw not just a moon, but a story waiting to be told. Now, as we shift our gaze from ancient myths to the world of art and literature, we find the moon continuing to cast its luminous spell over human creativity. For centuries, the moon has been a muse for artists, writers, and musicians. Its ethereal glow inspiring works that capture its beauty, mystery, and symbolic power. From paintings to poetry, the moon has served as a canvas for expressing the depths of human emotion and imagination. In the realm of visual art, the moon has been a recurring theme, often depicted as a serene and otherworldly presence. The Dutch painter Vincent van Gogh immortalized the moon in his iconic work Starry Night, where it glows alongside swirling stars, evoking a sense of wonder and introspection. Similarly, the German romantic artist Caspar David Friedrich used the moon in his landscapes to symbolize solitude and the sublime, as seen in his painting, Two Men Contemplating the Moon. These artists captured not just the moon's physical appearance, but its ability to evoke feelings of awe and contemplation. Literature, too, has been deeply influenced by the moon's allure. Poets like William Wordsworth and Percy Bysshe Shelley often turned to the moon as a symbol of beauty, longing, and the passage of time. In Wordsworth's poem To the Moon, he describes it as a wanderer through the heavens, a celestial companion to human solitude. Shelley, in his poem To the Moon, portrays it as a melancholic figure, reflecting the fleeting nature of life and love. These poetic interpretations remind us of the moon's ability to mirror our innermost thoughts and emotions. The moon has also played a central role in storytelling, appearing in countless novels, plays, and folktales. In Shakespeare's A Midsummer Night's Dream, the moon is a silent witness to the magical and chaotic events of the forest, its light guiding the characters through their misadventures. In more modern literature, the moon often serves as a symbol of mystery and transformation, as seen in works like The Moonstone by Wilkie Collins, where it becomes a key element in a tale of intrigue and discovery. Music, too, has been touched by the moon's enchantment. From classical compositions to contemporary songs, the moon has inspired melodies that resonate with listeners across generations. Ludwig van Beethoven's Moonlight Sonata is perhaps one of the most famous examples. Its hauntingly beautiful notes, evoking the quiet, reflective glow of moonlight. In popular music, songs like Fly Me to the Moon by Frank Sinatra and Moon River by Henry Mancini have become timeless classics, their lyrics and melodies capturing the moon's romantic and dreamlike qualities. The moon's influence on art and literature is a testament to its enduring power as a symbol of creativity and imagination. Whether it's a painter's brushstroke, a poet's verse, or a musician's melody, the moon continues to inspire us to explore the depths of our own humanity. As we reflect on these artistic expressions, we are reminded that the moon is not just a celestial body, it is a source of endless inspiration, a mirror reflecting the beauty and complexity of the human spirit. And as we continue to gaze at its luminous face, we carry forward the legacy of those who have found in its light a story waiting to be told. Now, as we turn our attention to the moon's role in measuring time, we uncover a fascinating intersection of astronomy, culture, and practicality. For thousands of years, the moon's predictable phases have served as a natural clock, guiding civilizations in their daily lives, agricultural practices, and even spiritual rituals. The waxing and waning of the moon provided an early framework for understanding the passage of time, long before the invention of mechanical clocks or digital calendars. In ancient societies, lunar calendars were among the first systems used to track time. The moon's cycle, which takes roughly 29.5 days to complete, became the foundation for months in many cultures. The Babylonians, for example, developed one of the earliest lunar calendars, dividing the year into 12 lunar months. This system influenced later civilizations, including the Greeks and Romans, who adapted it to suit their own needs. Even today, many traditional calendars, such as the Islamic Hijri calendar, remain based on the moon's phases, reflecting its enduring cultural significance. The moon's phases also played a crucial role in agriculture, helping farmers determine the best times for planting and harvesting. The new moon, with its promise of renewal, often marked the beginning of planting seasons, while the full moon's bright light provided extended hours for nighttime work. In some cultures, specific lunar phases were believed to influence the growth of crops, with rituals and festivals timed to align with the moon's cycles. This connection between the moon and the rhythms of nature highlights its practical importance in shaping human life. Beyond agriculture, the moon's phases have held deep spiritual and symbolic meaning. Many ancient religions and mythologies associated the moon with deities and cosmic forces. In Hinduism, for instance, the lunar calendar is used to determine the dates of festivals and religious observances, such as Diwali and Holi. Similarly, in Chinese culture, the Mid-Autumn Festival celebrates the full moon as a symbol of unity and abundance. These traditions underscore the moon's role not just as a timekeeper, but as a source of cultural identity and communal celebration. In modern times, while solar calendars have become the global standard, the moon's influence on timekeeping persists in subtle yet meaningful ways. The concept of a lunar month still appears in various contexts, from astronomy to astrology. Even our language retains traces of lunar timekeeping, with words like month and Monday derived from the moon. Additionally, lunar cycles continue to inspire scientific research, such as studies on how the moon's gravitational pull affects Earth's tides and ecosystems. The moon's ability to measure time is a testament to its profound impact on human history and culture. From ancient farmers to modern scientists, the moon has guided us in understanding the rhythms of life and the universe. As we reflect on its role in timekeeping, we are reminded of the moon's timeless connection to humanity, a celestial companion that has illuminated our past and continues to shape our future. And as we move forward, we carry with us the legacy of those who first looked to the moon, not just as a light in the night sky, but as a marker of time itself. Now, as we shift our gaze to the moon's ever-changing face, we find ourselves immersed in the captivating dance of its phases. The moon's phases are a direct result of its orbit around Earth, a celestial ballet that unfolds over roughly 29.5 days. As the moon travels around our planet, the angle between the sun, Earth, and moon changes, revealing different portions of the moon's illuminated surface. This cycle begins with the new moon, where the moon appears dark, and progresses through the waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, and finally the waning crescent, before returning to the new moon once more. Each phase tells a story of light and shadow, a cosmic rhythm that has fascinated humanity for millennia. The moon's phases have long held profound cultural significance, shaping traditions, rituals, and even daily life. In ancient times, the phases served as a natural calendar, guiding agricultural practices and marking the passage of seasons. Farmers relied on the moon's cycle to determine the optimal times for planting and harvesting, believing that certain phases influence the growth and vitality of crops. For example, the waxing moon was often seen as a time of growth and renewal, ideal for sowing seeds, while the waning moon was associated with harvesting and preservation. These lunar rhythms became deeply embedded in the fabric of agricultural societies, creating a timeless connection between the heavens and the earth. Beyond agriculture, the moon's phases have played a crucial role in navigation, particularly for seafarers and explorers. Before the advent of modern technology, sailors used the moon's position and phase to chart their courses across vast oceans. The full moon, with its bright light, provided illumination for nighttime travel, while the changing phases helped mariners estimate the passage of time and predict tides. This reliance on the moon's phases not only ensured safe passage, but also underscored the moon's role as a guiding force in human exploration and discovery. Scientifically, the moon's phases offer valuable insights into the mechanics of our solar system. By studying the interplay of light and shadow during each phase, astronomers can better understand the moon's orbit, rotation, and relationship with Earth. The phases also serve as a visual reminder of the moon's synchronous rotation, where the same side of the moon always faces Earth. This phenomenon, combined with the moon's phases, has inspired countless scientific inquiries, from the study of lunar geology to the exploration of its potential as a future outpost for humanity. Culturally, the moon's phases continue to inspire art, literature, and spirituality. From poetry that captures the ethereal beauty of a crescent moon to festivals that celebrate the full moon's luminous glow, the phases remain a source of wonder and inspiration. In many traditions, the full moon symbolizes completion and abundance, while the new moon represents new beginnings and potential. These symbolic interpretations reflect the moon's enduring influence on human imagination and creativity. As we reflect on the moon's phases, we are reminded of their dual role as both a scientific phenomenon and a cultural touchstone. They connect us to the rhythms of the cosmos, offering a glimpse into the intricate workings of our universe, while grounding us in the traditions and practices of our ancestors. Whether guiding ancient farmers, aiding explorers, or inspiring artists, the moon's phases continue to illuminate our understanding of time, space, and our place within the grand tapestry of existence. And as we gaze upon the moon's shifting face, we are invited to ponder the mysteries it holds and the stories it has yet to tell. Now, as we turn our attention to the invisible yet powerful forces at play between the moon and Earth, we find ourselves exploring the fascinating world of lunar tidal forces. These forces, born from the gravitational pull between our planet and its celestial companion, shape not only the oceans, but also the very fabric of Earth's rotation and the moon's journey through space. At the heart of this phenomenon lies the moon's gravitational influence, which tugs at Earth's surface, creating the rhythmic rise and fall of tides. As the moon orbits Earth, its gravity pulls on the water in our oceans, causing it to bulge outward on the side closest to the moon. At the same time, a second bulge forms on the opposite side of Earth, a result of the centrifugal force generated by our planet's rotation. These bulges are what we experience as high tides, while the areas between them experience low tides. This constant ebb and flow is a testament to the moon's quiet yet profound impact on our world. But the story of lunar tidal forces doesn't end with the tides. These same forces are also subtly reshaping Earth's rotation. As the moon's gravity pulls on Earth's oceans, it creates friction against the ocean floor, gradually slowing down our planet's spin. Over millions of years, this interaction has lengthened Earth's days, transforming what were once much shorter days into the 24-hour cycles we know today. This slowing effect is so gradual that it's imperceptible in our daily lives, but over geological time scales, it has had a significant impact on Earth's history. Interestingly, this gravitational dance is a two-way street. Just as the moon's gravity affects Earth, Earth's gravity exerts a force on the moon. This mutual pull has caused the moon to gradually drift away from our planet at a rate of about 3.8 centimeters per year. While this may seem like a small distance, over billions of years, it has added up, altering the moon's orbit and its relationship with Earth. Scientists believe that in the distant past, the moon was much closer to Earth, and its gravitational influence was even more pronounced, creating tides that were far more dramatic than those we see today. The implications of these tidal forces extend beyond just the physical changes to Earth and the moon. They also play a role in the stability of our planet's axial tilt, which is crucial for maintaining Earth's relatively stable climate. Without the moon's gravitational influence, Earth's tilt could vary more dramatically, leading to extreme and unpredictable shifts in climate over time. In this way, the moon acts as a stabilizing force, helping to create the conditions necessary for life to thrive on our planet. As we reflect on the intricate interplay of lunar tidal forces, we are reminded of the delicate balance that exists within our solar system. These forces, though invisible to the naked eye, shape the rhythms of our world and influence the very course of Earth's history. From the tides that lap at our shores to the gradual lengthening of our days, the moon's gravitational embrace continues to leave its mark on our planet, a silent yet powerful reminder of the cosmic connections that bind us all. And as we ponder these forces, we are invited to marvel at the unseen threads that weave the tapestry of our universe, connecting Earth and Moon in an eternal dance of gravity and motion. Now, as we shift our gaze to the Moon's age, we find ourselves unraveling one of the most intriguing questions in lunar science. Just how old is our celestial neighbor? Scientists have long sought to pinpoint the Moon's age, and while they've made significant strides, the answer remains a topic of lively debate and ongoing research. The most widely accepted estimate places the Moon's age at around 4.5 billion years, making it nearly as old as Earth itself. This estimate is based on the analysis of lunar rocks brought back by the Apollo missions. These rocks, formed from ancient magma, contain minerals that act as natural clocks, recording the passage of time through the decay of radioactive elements. By measuring the ratios of these elements, scientists can calculate how long ago the rocks solidified, providing a window into the Moon's early history. One of the key pieces of evidence supporting this age comes from zircon crystals found in lunar samples. Zircon is incredibly durable and can survive the intense heat and pressure of volcanic activity, making it an ideal timekeeper. These crystals contain traces of uranium, which decays into lead at a known rate. By analyzing the amount of lead present, researchers can determine when the zircon formed, offering a snapshot of the Moon's earliest days. However, not all scientists agree on this timeline. Some studies suggest that the Moon could be slightly younger, with estimates ranging closer to 4.3 billion years. This discrepancy arises from differences in the types of samples analyzed and the methods used to date them. For example, some researchers argue that the Moon's surface underwent significant melting and reformation after its initial formation, which could reset the radioactive clocks in certain rocks and skew the results. Adding to the complexity is the question of how the Moon formed in the first place. The leading theory, the giant impact hypothesis, suggests that the Moon was born from the debris of a colossal collision between Earth and a Mars-sized body. If this is true, the Moon's age should closely align with Earth's. Yet, some simulations of this event suggest that the Moon could have formed slightly later, leaving room for uncertainty in its exact age. Despite these debates, one thing is clear: the Moon's age holds critical clues about the early solar system. Understanding when and how it formed helps scientists piece together the timeline of planetary formation and the conditions that shaped our cosmic neighborhood. As new missions return fresh samples and advanced techniques refine our dating methods, we inch closer to unraveling this lunar mystery. As we ponder the Moon's age, we are reminded of the vastness of time and the intricate processes that have shaped our world. Each rock, each crystal, tells a story of cosmic collisions, molten oceans, and the slow march of time. And while the Moon's exact age may still elude us, the journey to uncover it continues to illuminate the wonders of our universe, inviting us to explore the depths of its ancient past. Now, as we step into the realm of imagination and storytelling, let's explore how the Moon's mysteries have captivated the world of popular culture. From the silver screen to the pages of novels, the Moon has long been a source of inspiration, wonder, and even fear. Its enigmatic nature has fueled countless tales, each reflecting humanity's deep fascination with our celestial companion. In movies, the moon often serves as a backdrop for adventure, mystery, and the unknown. Films like A Trip to the Moon, one of the earliest science fiction works, imagined a fantastical journey to the lunar surface, blending humor and curiosity. More recently, movies such as Apollo 18 and First Man have explored the moon's darker, more mysterious side, weaving narratives of hidden dangers and untold secrets. These stories tap into our collective imagination, asking what might lie beyond the reach of our telescopes and probes. Books, too, have long been a canvas for lunar mysteries. Jules Verne's From the Earth to the Moon envisioned a daring mission to the moon long before such a feat was possible, while H.G. Wells' The First Men in the Moon introduced readers to a lunar world teeming with strange life forms. These stories not only entertained, but also sparked curiosity about what might truly exist on the moon, blending science with speculative fiction. Even in music and art, the moon has been a recurring theme. Songs like Fly Me to the Moon and Moon River evoke a sense of longing and wonder, while artists have depicted the moon as a symbol of beauty, mystery, and the passage of time. Its phases and ethereal glow have inspired countless works, each capturing a different facet of its allure. What makes these portrayals so compelling is how they mirror our own questions and dreams about the moon. Whether it's the fear of the unknown, the thrill of discovery, or the simple beauty of its light, the moon continues to hold a special place in our hearts and minds. Through these creative expressions, we see not just a celestial body, but a reflection of our own curiosity and imagination. As we turn our attention back to the moon's scientific mysteries, let's carry with us the stories and dreams that have shaped our understanding of this enigmatic world. For in the end, the moon is not just a place of rocks and craters, but a canvas for our hopes, fears, and endless fascination with the cosmos. As we bring our journey through the moon's mysteries to a close, it's clear that this celestial companion remains a source of endless fascination and wonder. From its ancient volcanic plains to the enigmatic flashes of light on its surface, the moon continues to challenge our understanding and spark our curiosity. Each unanswered question, whether about its formation, its hidden water, or its magnetic swirls, invites us to look deeper, to dream bigger, and to keep exploring. The moon is more than just a rocky satellite orbiting Earth. It's a mirror reflecting our own desire to uncover the secrets of the universe. Its mysteries remind us that there is still so much to learn, not just about the moon, but about ourselves and our place in the cosmos. As scientists work to unlock these secrets, we too can join in this journey of discovery, letting our imaginations soar as we ponder the possibilities. So tonight, as you gaze up at the moon or drift off to sleep, let its gentle glow remind you of the wonders that await. Share your thoughts, your dreams, and your questions about the moon with others, and keep the spirit of curiosity alive. And now, as the stars twinkle above, and the night wraps you in its calm embrace, let the mysteries of the moon guide you into a peaceful, restful sleep. Sweet dreams, and may the moon's secrets continue to inspire you. If you enjoyed this journey through the moon's mysteries, don't forget to like this video, subscribe to the channel, and hit the notification bell so you never miss an exploration into the wonders of the universe. Thank you for joining us, and until next time, keep looking up.